Hey builders, in this Retro Reacts, we're going to take a look at an architecture from February in 2017 where CorpInfo was leveraging some AWS services to build a scalable stream management solution. Let's get started. So again, we're looking at these videos through the lens of the AWS Well-Architected Framework. We're seeing what worked then, what still is probably working there, and what we could change.
This is my architecture. I'm Dave, and I'm joined here by Tim from CorpInfo.
So we have a new AWS presenter right out of the gate. We've got David instead of Simon. Sounds like we're on the North America side as opposed to in Australia and New Zealand. But let's see what CorpInfo is trying to tackle, because this is also the most complicated architecture we've seen so far, even though it's still got just multiple instances of the same services. This again highlights how hard those geometrical isometric icons used to be. I don't even recognize half them. I kind of do. They're ringing a bell, but they're not nearly as clear as the new ones.
Info is a premier AWS partner, but what do you guys do?
So we specialize in helping companies get their stuff out to the cloud, specifically on Amazon. And once they get it out there, we can also run it for them because we're also a service partner.
All right, so a double threat. That's awesome. And you came here to talk today about an IoT device that delivers video to the cloud?
Okay, so CorpInfo is a partner that helps build and then run solutions, and they're going to talk about an IoT solution. Now, in 2017, if I remember right, IoT was really in its infancy when it came to AWS Cloud Services. It wasn't the full portfolio that we have today. So let's see what they had to cobble together given the what was available at the time.
What's going on here?
Yep, so we have a customer that has had some challenges in sort of figuring out how to actually get this IoT device to work in a scalable way. So for them, the big challenge was they started off as a small sort of company, and as they exploded, they ran into some sort of challenges in how they actually built things.
So this is a scalable challenge or scalability challenge, which is quite often, it falls under operations in the AWS Well-Architected Framework, as well as reliability and performance. It's the whole thing. But it wasn't uncommon early days, especially if you were basically building a service through the low-level components on AWS, that you had these challenges and you would engage with a consulting partner because they had better experience with the services. You're saying, I don't know how to get this to scale. And scale is a relative word. Some people would say, 1,000 devices, sometimes it's 10,000, sometimes it's 100,000 devices. Let's see if we get any indication of how many devices this company was trying to roll out.
So the dangers of scale, right? Like the traps and pitfalls.
Yep.
But you guys solved that in kind of an interesting way.
Yep.
So why don't you show us what you did?
Sure. So when you think about it, you actually have a device that sits out in the wild. And its whole purpose is to be event-driven. And once an event occurs, it actually records that video.
Okay, so it seems like a little bit of machine learning in the camera where it's going to trigger based on it seeing something, and then it actually kicks off an event. Very common workflow today, not so common back in 2017.
The challenge is as you get more and more devices, how do you actually scale that? At what point or what interactions do you have that sort of define the scale points in that environment?
So those scale points he's talking about really, for me, automatically trigger concepts of EC2 clusters, auto-scaling clusters. Normally, if you're running a website, you would say, available processing and available bandwidth. For IoT devices, that traffic might not be as obvious because especially with cameras, if there's a lot going on where those cameras are looking and there's a lot of cameras deployed, you could have a massive amount of traffic right away. Whereas if there's not much going on, you could have very little traffic. It'd be really hard to predict those patterns.
Part of it is when we actually looked at it, for us, it was looking at what needs to be sort of on a global scale and what can be more segmented to make it a little easier for that device to function.
So that's a good first slice of the problem, basically saying what are the global things that we need to worry about, and then what are the specific things for individual devices. So are there services in our stack that are serving everything and need to scale differently than stuff that are just maintaining devices, updating them, pulling in specific information from them?
Give you scalability. And the way we sort of looked at it was the concept of dividing those up into what we call pods, right? So the first part of that,
not Kubernetes pods,
is you on the global side, you have a service whose whole purpose is to sort of figure out where that device lives, or in the more basics, you have to do setup, you have to do user.
Okay, so they're basically building out some of the core AWS IoT services. And I wouldn't be surprised that if this is one of the driving use cases for those IoT services. But provisioning is a real big challenge, maintaining and operating those devices, because they're out there. They're in the physical world and you need to worry about them, but they're not full-fledged computers necessarily. They're, for a camera, it's attached to the side of a building. Hopefully it's got regular connectivity, but how do you manage that? And without a service built out for that, you have to build it yourselves, which is exactly what CorpInfo was talking about.
Up and control that information, as well as sort of keep the event stream, right?
Yep.
Okay, so they've got one service that's handling sort of the device and its operations, and then another, or it seems like they'll probably have another to handle the actual events coming from the device.
The second part of that is now once you actually have the device set up, it's when an event occurs, what do you do with it?
So basically they've got a control plane and a management plane. The management plane is managing the device. The control plane is going to be handling all the data from these events.
So the second part being, now you actually have a setup that actually controls all of the events with regard to recording the video, and then once you actually have that video, doing something else.
Okay, so we got the
plane,
out-of-the-box experience, right? Now we're taking an event, but where does it land?
Right. So once that event actually happens, and you actually get video that's coming in, the system is actually going to record the video on a...
Okay, so he's drawing a third stream. This will be interesting. We've got a clean division between managing the devices, making sure they're healthy, and the event-driven stuff. Now he's talking about the video stream. So when an event is kicking off, I imagine there's a number of things like, metadata around the camera's operations, but then a video stream is a pretty straightforward stream of data that they might be able to handle differently. Let's see where he connects this arrow.
Service. And when it records that video, it actually stores it in S3.
Dumps it into S3.
Okay, great place to land data.
Right. So when you come into the ELB, your
that's an ELB.
EC2 instance.
This is why I hate those icons. That's an ELB, which totally makes sense. So the data plane service is going to handle eventing information differently than it routes data. If it sees a video stream coming in, the ELB is just going to dump it right into S3, which is absolutely where it should go. And then it's going to handle the actual event data differently because you need to process on it. The event stream, the video, you just want to store. For the event itself, you actually want to do something, maybe notify, that kind of stuff. So that's those weird boxes with the little mini boxes in front of it, ELB.
Are actually taking the action to actually do things with, and they're actually storing information about that event actually in RDS database.
RDS.
Okay, great.
Dynamo's the
Awesome.
one above it.
So along with that, you need to understand how these events are showing. And one of the key things that sort of makes their problem unique is each user can have one device, but if somebody wants to use it, say you have one and I have one, and we both want to use it, now how do I get that information to your cell phone or to your
I don't know where he's going with this.
computer?
Right.
That becomes a different problem, right? Because now I have one video stored out on S3, but I need to be able to give everyone access to it.
Oh, okay. So basically what he's saying is now that you've stored the video, you need to be able to share that video out. So now we're going to walk through, hopefully, the solution for that, which is where the Dynamo icon, which you can see in the top left here, is going to come into play.
So how do we do that?
So part of that is
I hate the fake, oh, I've never heard of that. How do you do that? Like we didn't rehearse this 10 times, but I get it. You need to some level of performance, like this video you're watching me watch this video in. It's part of the delivery, which I get, but it's always like, okay, you know how they did that. You don't need to set up. This guy could have just given a straight to camera discussion of his architecture and shaved a couple minutes off this.
building on that global service for having something that understands where those users live. So when you come in through the ELB,
the management ELB.
you then have, of course, your EC2 instances that sort of direct that information, and you store the event stream in DynamoDB. So what happens is when you actually hit that front end, you actually are pulling back a stream.
So they're using the management data of what's happening to then help divide or share that data out, which is an interesting solution. I would have gone with the other plane, but I guess it's management information permissions. So keeping on the management plane.
DynamoDB of all of the events that are associated with you as a user. So even though you may be looking at somebody else's device, your event stream still contains all that information.
Okay, so that's a piece we're missing. This is one of the challenges of these videos is you don't have the entire architecture to see what was going on. And in this case, what was happening is that you may want to see my video and we're separate objects within the system. So this is how they're going to share it out.
And along with that event stream, we're going to direct you to the specific point to go get your video.
So like pointers in the database?
Correct.
Okay.
Yeah, you don't want to be moving the data around if you don't have to.
And it's blazing fast because it's Dynamo, right?
Yep. That's the advantage we get. And we can sort of scale that event stream in a variety of different ways. So if you want to look at that information, let's say there are different event types that can sort of occur.
Okay.
And you can segment those and create specific tables for each of those event types. And maybe
Though you shouldn't. You should only have one table and then a different event type item. But then again, this was a few years ago, and we weren't that great at leveraging all the Dynamo stuff.
it becomes a little counterintuitive that it's not necessarily, you think about doing something like that on a referential database, like RDS, but for the speed standpoint and the fact that this data is read very rarely, it sounds strange, but you spend more time writing information than you do actually reading it.
So
It's not strange, it's just your use case. There's a ton of use cases where you write way more than you read because it's historical and it's only reference. So you can see for a video solution like this, you may not review all the video unless something actually important happened, and then you go back and say, well, show me the video of the night of the 5th. Like, think crime drama, right?
Dynamo is a great choice, even though it's like not inherently relational, right?
Correct. In this particular case, especially because of that fact, right? Is if I was going to spend more time reading the information, there might be some other ways we sort of architect it.
Sure.
But
That's a great point. And I love that he brought it up, the gentleman from CorpInfo here, is that when you're picking a data solution, the number one thing you should be thinking about is how often you're writing stuff in and how you want to be reading stuff out. Because if you're reading far more often than you're writing, optimize your data structure within the data store for reading it out. Make it as easy as possible to read it out. If you're doing the flip side, make it as easy as possible to write it and harder to read it out. And what I mean by that is if you need to pull a bunch of things together on write to write it in a better way that makes it easier to read, do that or flip there. Basically, do the work where you're doing it the least often.
of actually how we're allocating what we're doing in Dynamo, it's heavy on the write side and lower on the read side.
So we can dial up the writes.
So this is, again, back before auto-scaling. So this they've tuned Dynamo, its capacity. They provisioned it very much for writing and as opposed to reading, which makes sense. And if their use case changed, they just turn those dials differently.
Correct.
And call it all good, right?
Correct.
Awesome.
Once all of this is done though, once you've actually collected the information, you have the event, you've recorded the video, and you've recorded maybe some interactions that the users have
We still have 2 icons. Are you going to connect the icons? Please connect the icons.
that video, so maybe you've understood how often they viewed it or anything else. You then want to be able to report on that information.
Right.
So as a
So now we're getting into some data reporting.
I need to be able to sort of collect that information and have a method by which I can actually see what occurs. So from that standpoint, you're then taking the information out of our RDS about about the users and everything else. You're also taking the event streams
From the 2
and
data
you're shoving
sources.
them into Redshift. So
Into
now you
Redshift.
can actually have
My
reporting on
Lord,
it.
okay.
So events, user.
So Redshift's a big clustering data warehousing solution. And if you have enough data to justify it, it makes sense. And I think they would at this scale. But again, they haven't given us specific numbers. Let's just assume they have the scale to justify it. They're essentially using Redshift to unify the data in Dynamo and in RDS.
Interactions, and we've got all this metadata, put it into Redshift, and magic happens, right?
Right.
Awesome.
That's the whole intent.
Well, this is a really great solution, and I really found it interesting how you were able to.
You didn't use the punching post at the top. No punching post at the top. How come that wasn't used? Anyway, interesting solution. At the time, totally makes sense because the IoT services weren't available. Nowadays, this would look completely different. Same concepts. You want data plane and management plane or control plane, but you'd be using the IoT services for device provisioning, for device monitoring, for security, like IoT Device Defender. But you'd have the same concept as far as events would be going into Dynamo, probably into one table with different event types. You would remove the auto-scaling clusters. You would remove the RDS database entirely, store everything in S3 for the reporting. I'd use a combo of Athena and QuickSight so that we'd go to an entirely serverless design for this because that's going to scale better and that's going to directly align your costs with these events. You'd have your management events and you have your database data events for the video streams themselves. But the same thing would be happening would be the cameras would record directly into S3 whether you go through a load balancer or not. But yeah, I would strip away some of these pieces to new pieces that simply weren't available at the time. So this is a great solution at the time. Kudos to CorpInfo for coming up with it. And this would have scaled. This would have met that scaling challenge. The issue here is that you're scaling 2 different clusters of EC2 instances. This was before auto scaling on Dynamo even, and you're paying for those Redshift clusters as well as the RDS clusters. This would have been very expensive. but it would have been really an efficient way to solve the problem at the time. Now we have better options. That's a core takeaway from the AWS Well-Architected Framework. I've said it before, I'll say it again. You really need to have a feedback loop where you can evaluate new services as they come in, sort of extrapolate the cost of shifting over to those new resources if they're a good fit, and figure out if that makes sense or not. So something like IoT device provisioning absolutely would make sense to go with the AWS core service, because there's a whole bunch of really complicated stuff there that they just take care of. You just say, give me a new device, it's registered, off you go. Similarly, moving to a serverless based design, you may have to shove a little bit of Lambda in there, but I actually don't think so. A lot of this would be native. You may just have some Lambda into writing events into Dynamo to make sure that you're writing the right thing. But other than that, you'd be able to switch this to a far less operational burden by going serverless. You directly align those costs so you know how much a device was costing you for management, and then you'd obviously have a very clear definition of how much video is costing you per minute. So you could probably adjust your business model, or at least fine-tune your business model to keep those profit margins high and your operational overhead low. But for the time, this is a great way to solve it. It totally makes sense. I like the division of control plane and the data plane, and it held up. I'm sure you could still solve the problem this way. It's just there are better ways to move some of that burden, especially around provisioning. I really can't stress how challenging that is. Move that to AWS is going to save you a huge amount of headache. But for the time, great solution. I love it. And I will see you in the next video.